as factoring, square root method, completing the square, quadratic formula. The first type of problem we're going to look at today have fractional expressions, things with fractions in them. How do we go about solving these problems? The first thing that we have to do on these is think about what kind of answers can we have. When I have a fraction, what is the one thing that can never happen? More specifically, think about the denominator. What can't you have in the denominator? You can have a variable. We can divide by a negative. What number can you not divide by? 0. So if it's a fraction, I know the denominator can't be 0. Now 2 is never 0. I don't have to worry about that. What would make x minus 1 equal 0? 1. Okay, so this is kind of a note to myself. I know that the bottom can't be 0, so x cannot equal 1. I typically write that out to the side. That's your domain. X can be any number except 1. What happens if I solve this problem and I get 1 for my solution? We either got messed up somewhere or the answer is really no solution. The only number that could make it work really doesn't. So on these problems, we are going to have to check our answers and make sure they're reasonable. Now, there are two different approaches we can take to solving these. One of them is to get a common denominator and work from that point. The other is to get rid of the fractions. So, do you guys like fractions? No? Let's get rid of them. If I want to, I'm going to rewrite this. I need a little more space between my terms. Okay. If I want to get rid of this denominator, what would I have to multiply by? 2. But in the equation, we know we have to take each side times 2, right? That means every single term gets multiplied by 2. So I'm going to take everything times 2 because that would cancel my first denominator. Look at your second fraction. It was x minus 1. So what do we have to multiply by? X minus 1. Every single term has to get multiplied by it. It's an equation. Keep it balanced. If you do it to one term, every term gets it. Now, I no longer have fractions. You're welcome to start multiplying. For the sake of being clear in my notes, I'm going to write out exactly what I have left. So in the first one, I have 2x minus 3 times x minus 1. Second term, we have 2x times 2. And over here, 2 times x minus 1. Is this an equation we could all solve? I think so. We just start multiplying things out. So if we FOIL, we get 2x squared minus 2x and minus 3x should be minus 5x plus 3. Plus 4x equals 2x minus 2. What next? Yep. So I did my negative 5x plus 4x. Now this is a quadratic. What do we always need our quadratics to be equal to? 0. So if I subtract over my 2x, add over my 2, did I lose anybody by not showing my work, how I brought that over? I can write it out if I need to. Do we have a question?
How did the x become a 1 in the second step?
Oh, did I copy my problem down wrong? Thank you. See, you guys have to tell me when I do that. I did it on purpose just to see if you were paying attention, and you guys all failed. Except the back table. That was whispering, but didn't tell me what they were whispering about.
I didn't write it. Oh my gosh.
My one became my x became a 1 as I said. Okay, so this works out even better, because what happens when I subtract over my 2x? That cancels. So if I add over this x, divide, and x is negative 3. Alright, what answer did I say we couldn't get? 1. We didn't get that, so it should work. How could you check yourself if you really wanted to? Plug it back in. So, at the very least on these, you need to check and make sure that your denominator isn't 0. On a test or quiz, may not be a bad idea to take the time to pick up a calculator, plug it back into the original problem, and make sure it really does work out. Is that one okay? We're going to work a few of these together. So here's our next problem. Can you tell me what x cannot equal in this one? 5. We can't have a positive 5 because then the denominator would be 0. Okay? So if I want to cancel the first fraction, what do we have to multiply by? If you do it to one term, you do it to all. Remember, the terms are separated by addition and subtraction signs. Now, lucky for me, those cancel, and these cancel. So do I even have any fractions left? No, that's all we had to multiply by. So we're left with x plus 5 times the x minus 5 equals 5. You're welcome to go ahead and start multiplying that out. I'm just trying to show my work so you know where I got my answer. You okay? Alright, so 5x plus x would be 6x. So we get 6x equals 30, so x is 5. What's wrong with that? Can't be 5. We said at the beginning, any number in the world would work except 5, and that's what I got. So what's my answer? There is no solution. Alright. On these problems, we have to be careful that we are not making our life harder than it has to be. We don't want to create more work for ourselves. So let's say I gave you this one. What about this problem makes it harder? Okay, we have 3 fractions in it. What do you notice about the denominator on the right-hand side? X squared minus 2x. Right, we have exponents in it. We could multiply by all of these things. But I really don't want to multiply by an x minus 2, an x, and an x squared minus 2x. Because I'm going to end up doing a lot of FOILing. I'm going to end up with a massive polynomial to set equal to 0 and solve. So, before you multiply by anything, what you need to do is make sure all of the denominators are completely factored. So x minus 2, I cannot do a thing to that. X, I can't do anything to that. But what can we do with x squared minus 2x? Take out the x. So always make sure your denominators are factored. Can you tell me right now, what can x not equal? 2. Anything else? 0. I can't have a 2 because that makes x minus 2 0. I can't have a 0 because this is the denominator of x. Okay, so we can have multiple answers that x can't equal. So if I'm going to get rid of my fraction, the first denominator has x minus 2, so I have to take everything times an x minus 2. That cancels this. It also cancels the x minus 2 on the right-hand side. What else do we need to multiply by? X. So everything gets a plain x. That cancels this denominator and this one. If we hadn't factored, we would now be multiplying everything by an x squared minus 2x. But because we factored, that denominator has already canceled out, and we are ready to solve our problem. So what I'm left with, the first fraction, we have the 3x plus 2 times an x. The second one, I have a 1 times an x minus 2. Over here, I just have negative 2. Or if you multiply that out, you get 3x squared. What?
Does the x not cancel? So
It has to be the entire so I can't cancel this x without it because this one has an x minus 2. That's why I try to write them in parentheses so I never
but then we took like another x into the so does that not cancel again? It actually cancels this.
Okay. So if I combine like terms, we get 3x squared plus 3x. If I add over my 2, that drops. What would you do next? That leaves us with x plus 1. So what does x equal? 0 and negative 1. But we have to check, are both of those answers okay? No, we made ourselves a note at the beginning that x could not be a 0 or a 2. So negative 1 is the only answer that works. And you can certainly plug it back into the original problem to verify that. All right. Yes. Other questions? Okay. You guys need to try one on your own. Because if you put 0 back into the original, you get 1 over 0, which doesn't work. Any other questions there? So here's your problem. Make sure you factor first. So you're not making your problem more complicated than it has to be. There are 2 ways we talked about. Common denominator is an option, but we've been trying to get rid of the fractions. Make sure you're not doing a combination of the 2. So, can't do anything with x minus 1. Can't do anything with x plus 1. But what about x squared minus 1? What does that turn into? Okay, so first we factor. What can x not equal? Okay, so that's just my little thought bubble for when I get to the end. I know that can't be an answer. All right. Now, what we have been doing is saying, what can I multiply by to cancel my fractions? This denominator is x minus 1. So if I want to cancel it, I need to multiply by x minus 1. I'm not doing it on the top and bottom. I'm just taking it to the numerator of every term. Okay? When I do that, this cancels, and these x minus 1s over here cancel. Now,
You got it, spit it out.
Okay. How did you get x plus 1 and x minus 1?
Difference of squares.
So you don't do you don't do this thing. But why don't we do the x parentheses x minus 1?
because that's a GCF. That would be like if they
So we don't want to do that.
S.
Yeah, there's an x by 1, so you can't do it.
This is our factoring where you're basically saying what two numbers.
So we're not taking out a greatest
There is.
This one right here has x right here.
get x out, but this one doesn't have an x behind it. So you can't take an x.
So why would you do that?
Okay.
All right, everybody back with me. So when I look at this, yes.
Oh yeah, the first, the negative 4x.
Oh, thank you. When I look back at this, I still have a fraction. So we have to get rid of it. We're not done. We still have x plus 1 on the bottom. So everything needs to be multiplied by an x plus 1. Okay, that will cancel this and this. So at this point, in the first one, I had the negative 4x and we have an x plus 1 remaining. In this term, we had a 4 and we have an x minus 1 remaining. Over here we had negative 8 and everything else dropped out. So now we multiply it out. So negative 4x squared minus 4x plus 4x minus 4. So negative 4x and positive 4x cancel. If I want to add my 4 over, what would I do next? Divide by negative 4. How do you get rid of a square? And with that, we always do the square root of 1 is 1. Now, at the very end, we have to check ourselves. What did we write down at the very beginning that x could not be? 1 and negative 1. So what does that mean? No solution.
Wait, why would I have negative 5 and negative 4?
I know, but where did it go as an answer?
Because when you divide negative 4 by negative 4, you get positive.
Oh, yeah.
Okay, other questions? All right.
So you don't multiply the negative 8 by the x and 1?
No, because it canceled out.
X and y.
X and 1.
Oh, it is y.
No, because it canceled out the one on the bottom.
You only multiply by what's left after you canceled out the bottom. Other questions?
Okay. No, okay. Yeah.
And then you divide by negative 4.
Got
Oh, but it would say, so it would say.
Oh, yeah, that's just.
Okay. Let's take a look at this problem. So we are going to come back and do more of these. We're spending all week on this section, so we are going to do some more rational ones, but I want to look at a problem that has a radical in it and talk about what kind of strategy we might use here. Question? All right. If I'm trying to find x, x is under my radical. So I have to get that radical by itself. How would I get my radical by itself? Add this 2 over. So that tells me the cube root of 2x minus 4 is equal to 2. I'm trying to get to x. It's under my radical. What is the opposite of a cube root? Cube. So I'm going to cube each side of this equation. So over here, my cube root and my cube cancel. Over here, 2 to the 3rd power is 8. So if we add over the 4, divide by 2, and x is 6. What should I do now? Yep, we always want to check, just make sure our answers work. It's not like the fraction problems where we listed out what wouldn't work. So just make sure, plug it back in the original. If you put in the 6, you get the cube root of 8 minus 2 equals 0, and it does. All right. Final problem of the day.
Oh, no. So what do you take the local to?
Okay. So yes, to get rid of a square root, we square. Now, here's the thing you need to remember. When you square, you are squaring the entire side. So on the left, it cancels the square root. How do I take x minus 7 and square it? Well, so I get x squared minus 14x plus 49. Right, we need it equal to 0. So if I subtract over my x and add 1. Now what do we do? What multiplies to a positive 50 and adds to negative 15? So then if you set those equal to 0, what do we get? Okay. Check. If you put in a 10, so 10 minus 1 is 9. Here 10 minus 7, so 3 equals 3. That's good. But if I put in a 5, look what happens. I get the square root of 4 equals 5 minus 7. Square root of 4 is 2. 5 minus 7 is negative 2. So did that one work? No. Sometimes when you square, you get answers that don't really work. 10 is the only option that does. All right. We are partway through this section. tomorrow, we're going to keep working on it. Thursday, we will go back and review all of it again. So we have a few different types of equations. We looked at 2 today. We will spiral back and look at them again. I'm going to give you some book problems. Now, what I'm going to do is make all the book problems due on Wednesday, but I'm adding to it tomorrow. So is it a good idea just to do nothing today and think you'll have all class tomorrow? No, that's a bad idea. I'm giving you that extra day, so if you are having trouble, you can come in and get help.
So is it doing Wednesday?
So, tomorrow's Wednesday, Thursday.
Yeah, I was gonna say.
So, this is the assignment. Just a second, and I will clarify a couple things. Due on Thursday. There will be more problems tomorrow. There will be a quiz Friday. Now, something I do frequently. Do you guys know what I mean by EOO? It's every other odd. So I'll do 7, skip 9, do 11, skip 13, do 15. So if you have trouble doing every other, those are the problems. Make sure, what kind of problems did I give you? Evens or odds? Odds. Odds, guess what? The answer's in the back of the book. So do you think if you just hand me a piece of paper that has the answers written on it that you get credit for it? No. I gave you the odds so you can check yourself as you go. But you have to have work to justify your answers. So, those are your problems, and you've got a little bit of time now to